Imagine losing a spacecraft because someone used pounds instead of newtons, or watching a rocket explode because one number was too large for its computer. Disasters rarely begin with explosions. They begin with something small, one incorrect unit, one confusing sentence, one missing warning, and none of these disasters were caused by one careless person alone. Each mistake passed through multiple systems and survived several opportunities to be discovered. That is what makes them terrifying. These are 7 tiny mistakes that caused massive disasters. Number 7, the Mars Climate Orbiter, the wrong units. In December 1998, NASA launched the Mars Climate Orbiter. Its mission was to study the Martian atmosphere, monitor its weather, and help relay communications for another spacecraft. For 286 days, it traveled hundreds of millions of kilometers through space. But as it approached Mars, something was wrong. NASA's navigation team believed the orbiter was following one path. In reality, it was flying dangerously low. The problem came from 2 teams using different measurement systems. Software created by Lockheed Martin calculated the force from the spacecraft's thrusters using pound seconds. NASA's navigation software expected Newton seconds. One system was using English units, the other was using metric. The numbers were transferred correctly, but their meaning was completely different. Every course correction moved the spacecraft farther from where NASA believed it was. The orbiter was expected to pass safely around 226 kilometers above Mars. Later calculations suggested it came within roughly 57 kilometers of the surface, far too low to survive. The signal disappeared and never returned. A spacecraft that had crossed interplanetary space was lost because 2 teams attached different units to the same numbers. But NASA's investigation made something important clear. The mistake was simple. The real failure was that none of the checks caught it. Number 6, Ariane 5 Flight 501, the reused code. On June 4, 1996, Europe's new Ariane 5 rocket lifted off for the first team. It carried 4 scientific satellites and represented years of work. For the first 36 seconds, everything appeared normal. Then both guidance systems failed. The rocket suddenly turned, began breaking apart, and activated its self-destruct system. The entire mission was gone in about 40 seconds. The cause was hidden inside software originally written for the older Ariane 4 rocket. Engineers had reused part of its navigation program. The program converted a velocity measurement into a 16-bit integer, a digital container with a limited range. But Ariane 5 accelerated differently from Ariane 4. Its horizontal velocity produced a number too large to fit inside that container. The conversion caused an error, and the first navigation system shut down. The backup system was running identical software. It encountered the same number and shut down too. The rocket's computer then interpreted diagnostic information as real flight data and commanded a violent correction. Even stranger, the failed software function was only needed before launch. It had been left running because that had worked safely on Ariane 4. The old code was reused. The old assumptions came with it. One number destroyed the entire rocket. Number 5, the Hyatt Regency Walkways, the changed drawing. On July 17, 1981, hundreds of people gathered inside the Hyatt Regency Hotel in Kansas City for a dance. Above the crowded atrium were suspended walkways made from steel and concrete. The second-floor walkway hung directly beneath the fourth-floor walkway. At around 7 o'clock, their connections failed. Both walkways crashed onto the crowd below. The collapse killed 114 people. Investigators focused on the steel rods holding the walkways in the air. The original design showed one continuous rod running from the ceiling through the fourth-floor walkway and down to the second-floor walkway. During construction, that arrangement was changed. Instead of one continuous rod, 2 shorter sets were used. The modified version looked almost identical, but it completely changed how the weight moved through the structure. The fourth-floor connection now supported its own walkway and the entire second-floor walkway hanging beneath it. Its load was effectively doubled. The change was approved without the necessary calculations being properly completed. Investigators also discovered that even the original connection was too weak. So this was not simply one bad drawing. It was a weak design, a dangerous modification, and a review process that failed to stop either one. For months, the walkways appeared solid. Then a hidden connection became the point where everything failed. Number 4, Piper Alpha, the missing warning. Piper Alpha was an oil platform in the North Sea. On July 6, 1988, workers were performing maintenance on a condensate pump known as Pump A. A pressure safety valve had been removed and the opening was temporarily covered with a metal disc. The pump was not safe to operate. A permit explaining this existed, but the information was not properly communicated during the shift change. Later that evening, the platform's other condensate pump stopped working. The control room needed a replacement. They found paperwork suggesting Pump A was unavailable for one maintenance job, but not the separate warning about its missing safety valve. Believing the pump could be used, they started it. High-pressure gas escaped and ignited. The first explosion damaged critical systems, and the fire spread. Nearby platforms continued feeding oil and gas through connected pipelines, supplying the fire with even more fuel. Of the 226 people on board, 167 died. The investigation uncovered deeper failures in training, maintenance, emergency planning, design, and management. But the chain began with something painfully ordinary. One shift ended, another began, and one critical warning failed to move with it. Before we reach number 3, subscribe if you enjoy entertaining stories about the strange mistakes and disasters that shaped history. It helps these badly drawn people survive long enough to appear in another video. Number 3, Tenerife, the confusing clearance. On March 27, 1977, 2 Boeing 747s were diverted to Los Rodeos Airport on Tenerife. The small airport became overcrowded. Aircraft blocked the taxiway, forcing planes to taxi directly along the active runway. Then thick fog covered the airport. The control tower could no longer see the aircraft. A KLM 747 reached the end of the runway, turned around, and prepared for departure. A Pan Am 747 was still taxiing somewhere ahead, hidden in the fog. The tower gave the KLM crew instructions describing the route they should follow after takeoff. That was not permission to take off. But the KLM captain began advancing the throttles. The first officer radioed that they were at takeoff. The wording was dangerously unclear. The controller responded with "okay" before telling them to wait for clearance. At almost the same moment, the Pan Am crew transmitted that they were still on the runway. The simultaneous messages interfered with each other. The warning became a burst of noise. The KLM aircraft accelerated through the fog without takeoff clearance. Its crew did not see the Pan Am jet until it was too late. The aircraft collided, killing 583 people. It remains the deadliest accident in aviation history. One confusing sentence did not cause the disaster alone. There was fog, congestion, radio interference, cockpit pressure, and no ground radar. But the accident showed how deadly ordinary language could become when people interpreted the same words differently. Aviation communication was later made far more standardized. Because one unclear word can place 2 aircraft on the same runway. Number 2, Challenger, the frozen O-ring. On January 28, 1986, the Space Shuttle Challenger stood on its launch pad in unusually cold weather. Inside its solid rocket boosters were small rubber seals called O-rings. Their job was to seal the joints between metal segments and prevent burning gas from escaping. Engineers had already seen evidence that the seals could be damaged during previous flights. They were especially worried about how the rubber would behave in the cold. The night before launch, engineers recommended delaying the mission. During discussions with managers, that recommendation was reversed. The launch went ahead. At liftoff, the cold O-rings did not seal the joint quickly enough. Hot gas escaped through the side of the right booster. For a moment, material produced by the burning fuel partially sealed the opening. Then the shuttle encountered strong aerodynamic forces. The temporary seal broke. A flame escaped from the booster and damaged the external fuel tank. 73 seconds after launch, Challenger broke apart. All 7 crew members were killed. The O-ring was small enough to hold in your hand. But Challenger was not only a technical failure, it was also a failure in communication and decision-making. Previous damage had not caused a disaster, so each successful launch made the danger feel more acceptable. People had slowly become comfortable with a risk that already existed. Number 1. Chernobyl, the shutdown button. In the early hours of April 26, 1986, operators at the Chernobyl nuclear power plant were conducting a safety test. The test had been delayed and the reactor was eventually brought down to an unstable level of power. Operators attempted to raise it again, withdrawing more control rods than normal. Several safety systems were disabled or bypassed so the test could continue. The reactor entered an extremely dangerous condition, then its power began rising. An operator pressed the AZ-5 emergency shutdown button. That button was designed to stop the reactor. It inserted control rods that were supposed to absorb neutrons and reduce the reaction. Instead, for the first few seconds, it did the opposite. The reactor's control rods had graphite sections at their tips. As the rods entered the core, those tips displaced water. Under normal conditions, the effect was manageable, but the reactor was no longer under normal conditions. In its unstable state, inserting the rods briefly increased reactivity in the lower core. Power surged violently, fuel channels ruptured. Steam pressure exploded through the reactor, followed by another explosion. The building was torn open and radioactive material escaped into the atmosphere. The shutdown button did not single-handedly cause Chernobyl. The disaster required unsafe decisions, an unstable reactor, hidden design flaws, and a terrible safety culture. But that final detail made it almost unimaginable. At the worst possible moment, the crew activated the system designed to save them, and the reactor accelerated toward destruction. These disasters were not really caused by one unit, one number, one drawing, one warning, one sentence, one seal, or one button. They were caused by systems that allowed small mistakes to travel too far. Every error had multiple chances to be discovered. Someone could have questioned the units, tested the reused code, recalculated the connection, passed on the maintenance warning, waited for an unmistakable clearance, listened to the engineers, or revealed a dangerous design flaw before an emergency exposed it. The smallest mistake becomes deadly when every layer behind it fails too. Which disaster shocked you the most? Let me know in the comments and subscribe for more entertaining explanations, strange history, and unbelievable true stories. Because history's biggest disasters often begin with something small enough to ignore.